Here's an example in which we're going to have to calculate acceleration. This is a more challenging problem because you're going to provide two different answers. One answer is going to be in miles per hour, and the second answer is going to be in miles per minute. This isn't an exact example of what I've done in my classes. We've definitely converted the 15 minutes to hours, but I also want to introduce what if we changed it to miles per minute and how we would do that. So first, it's important we got to write down the formula for acceleration. Acceleration equals our final velocity minus our initial velocity over time. And you can also rewrite that as your change in velocity over time. So in this problem, within 15 minutes, we increase our speed from 25 miles an hour to 75 miles an hour. That's a 50 mile an hour difference. So I'm going to do this problem once we start calculating it in a different color here. So that means 50 miles per hour over a period of 15 minutes. Now, if you watch the velocity videos I did, I emphasize how important it is to write those units of measurement in, and it really is so important because we can see we have miles, we have hours, and we have minutes. Hours and minutes are both units of time, but they're not the same units. It's the same concept of adding inches and centimeters. You have to convert one to the other in order to get the actual value once you add them together. But in this problem, the question is asking for us to provide two separate or distinct answers, one in miles per hour and one in miles per minute. So I'm going to break this problem up into two separate problems. That way you can kind of see the difference. Everything's going to equal A. Everything's still going to equal acceleration. I'm just going to simplify this in two different ways. So at this time, I would pause the video if I were you, just to make sure you have everything ready, all set up, because we're going to go through the conversions here and that might get a bit confusing. So for the first one, we'll do this one in green. Miles per hour will be in green. You can see here I already have miles per hour. It's the minutes that I need to change. So what I'm going to do is in my denominator, I'm going to multiply that 15 minutes by a value that equals 1. That way, nothing changes. So in order to do that, we're going to convert this minutes to hours by taking this minutes and putting minutes on the bottom so they cancel out. And we'll put minutes on, or hours on the top. 1 hour equals 60 minutes total. Now, I know for a lot of people you're looking at this and you're thinking, how does this value equal 1? And aren't I changing the whole thing by doing this? And the answer is no. It equals 1 because you have two equal values divided by each other. You take 3 divided by 3 and it equals 1. You take 50 divided by 50 and it equals 1. In this case, you have two identical values, but the numbers are different because the units are different. So we know 1 hour equals 60 minutes. We're dividing 1 hour by 60 minutes, two values that are equal, so this equals 1. Now, as a result, we're going to end up canceling out these minutes. Now all we have left are miles per hour over hours. And that's an important part of the problem as well because that kind of leads us to our answer when it comes to the units given in acceleration. So what I'm going to do now, I'm going to calculate this. I'm going to figure out what is 15 divided by 60. A lot of you guys, without doing this step, can figure out 15 minutes is 0.25 hours simply by looking at a clock and noticing that that clock is exactly 1/4 when you have a 15-minute mark. So this bottom part equals 0.25. So we're going to take the 50 and divide it by this whole value. And I can actually write out my work up here. I didn't want to run out of room and make it too confusing. Miles per hour equals 0.25 hours, so a quarter of an hour. And I'll write my final answer down here. 50 divided by 0.25 is 200 miles per hour. And I know a lot of my students are thinking, you know, this is crazy. That's a really large number. We never hit 200 in this problem. But you have to consider, you're starting at 25 miles an hour, and after only 15 minutes, you increase your speed to 75 miles an hour. In a situation in which you are constantly increasing your speed at that same rate for 4 times this amount, or the opposite of this, the inverse of 0.25, so 4 times this amount, eventually your change in speed is going to be 200, but I actually made a mistake here. The unit for acceleration is miles over hours squared. And the reason why that is important is because for every hour, so notice how I'm emphasizing hour, our speed increases by 200 miles for that hour. So I had to say hour twice. So 200 miles an hour for that hour. So we're going to square our time. Acceleration, your time is always squared. Now let's calculate the same thing in miles per minute. This value might make a little more sense simply because we're measuring our time in minutes, and we're doing this within a matter of 15 minutes instead of a full hour. So we're going to start off the problem the same way. I'll have a nice big fraction. 50 miles over hours over 15 minutes. But I want my answer in miles over minutes. So I'm going to change this hours right here. And I'm going to change this hours by multiplying by a value. Hours is on the bottom. I want to cancel that out. There's another reason why units are so important. I want to cancel this value out, so I'm going to put it in the top of this fraction and then convert this to minutes. In 1 hour, there's 60 minutes. So now my hours cancel out. I have miles over minutes over minutes. That's the same thing as minutes squared. So I know my final answer is going to be in miles over minutes squared. That's how it always works out. So I'm going to show a little bit of work over here off to the side. 50 divided by 60 is in my numerator. That gets me 0.3 repeating miles over minutes. And I'm still going to divide that by 15 minutes. So we end up getting, for each minute, you get 0.06 when you round it miles over square minutes. And that also seems like an extremely small number as a result, but I'll go ahead and explain why we end up getting something like that. So we're originally measuring in miles per hour. Now there are 60 minutes in an hour, which dramatically decreases our number. So that means for every minute, we are increasing our speed by 0.83 miles in that minute, which isn't quite a lot because we're looking at a very small amount of time, and this is a very gradual acceleration. If you've ever driven from 25 miles an hour to 75 miles an hour and increase your speed, usually that takes less than a minute if you're driving safely, or around a minute 30 seconds if you're driving safely, depending on the situation. 15 minutes is an extremely slow rate of acceleration if you look at each particular minute. And that's what we're looking at here. So either way, we're going to come up with some obscure answers. Personally, I believe this one makes a little more sense because we're used to miles per hour, not miles per minute. But this is an example of how you would calculate your acceleration in two different units.